Have we taken a picture of the fridge?
We have not taken a picture of the fridge yet, but we have a fridge.
There is a fridge.
There
is
a
a fridge. Guys, there's a fridge.
Yeah.
just
Fridge.
Yeah.
To fridge.
Oh, I'm so happy that my naming idea worked out.
I'm really glad that we actually had a fridge, by the way. Like, we asked, and James was like, no, we don't have a fridge. And then we opened something up, and James was like, holy crap, we have a fridge!
I had a suspicion, because I was like, wait a minute. This is an expensive hotel room.
One would expect that you would have a fridge.
Then, yeah, so while Curtis was standing there, I awkwardly opened the door while he was right next to it. I was like, we have a fridge.
And I went, cool, we have a fridge.
And then John Hammond said...
Expect no expense.
Did your fridge have mysterious green Starbucks liquid in it?
No.
I don't believe that mine was meant to have that, but it was an unopened bottle of something.
Decidedly not.
Did
no.
they provide you with Soylent Green?
I don't know. Maybe. Because that's a real company now.
Yeah, Soylent is a real company. And we're in Seattle / Techland, so or Techland adjacent. So Soylent is
Techland adjacent.
It's not. It ain't San Francisco, but it's close.
Yeah.
So, this is day one.
Day one.
Day one is in the books, guys.
Mm-hmm.
So James,
I'm done.
You are done.
I've been done since 12. I am officially finished with GSA.
So what you're saying is that you will have no comments for the rest of this particular conference because you are done.
I'm not going to other talks. I just came here for me. Yeah, no, I'll go to talks. Probably more than I did today because after midday I failed to attend any talks.
It was a hard day to adjust and keep everything going.
Yeah.
It's still jet lag time.
A little bit. But we are in Seattle, GSA 2017.
Mm-hmm.
And, I guess, do we want to kind of go around and each kind of propose one talk that we'd like to talk about?
One?
Well, no, we can do it as a circle. And
Yeah,
then, and
okay.
then eventually when we're done...
That's great. When Brendan inevitably always says a talk I want to talk about before me, I'll just go pass.
Well, this is just like punch buggy rules. Like, as you say something...
It's all right. We can all find the same talk interesting.
Yeah, I'm just saying propose something to talk about.
All right.
Everyone can talk.
Well, why don't you open then?
Yeah, James. That way you get to start, and that way you
I
can...
can't steal yours if you start.
That's very true.
You'll find a way.
James, life finds a way.
Okay, I'll go in chronological order.
Which is your talk?
But he's not going to propose his own talk.
I'll
propose your talk.
No. I didn't want to talk about my talk when I was giving my talk. And Melanie didn't want to talk about hers either. She talked it all up, and then she was like, okay, let's just get this done so I don't have to do it anymore. That's the last thing she said to me before she went and gave her talk.
It's everyone giving a talk. That's everyone giving a talk. And then afterwards, I'm like, people are like, how was it? And they're like, it's fine, it was good. Like, really? And there's like this shell shock, like vacant stare in their eyes.
I do actually, the one thing I enjoy about giving talks, especially talks that go well, not this one, is the amazing buzz and high you get afterwards.
Yeah.
It might be because I am a, vacillating personality anyway, but I love the feeling of having accomplished something, even though that accomplishment is surviving having to talk for 12 minutes.
My accomplishment is I got this into the 13 and a half minute window.
That's going to be an accomplishment for me.
That's when I feel relief.
It's okay, our entire session was consistently running 5 minutes behind.
I noticed.
It's wonderful.
But it was not my fault this day.
No, you kept to time and gave a very engaging talk. Which I didn't write about because you're on this show now. But we can talk about it.
Wait, you did actually. You said there's a thank God Brendan and a smiley face.
Yeah, I need to photograph that for when I'm crying, when I'm actually writing this up.
I mean, it was getting dark. We're in the dark part of the trilogy. And
so
then
the
Brendan
Empire
was the saviour.
Okay.
No, not that trilogy. I mean, dark is in Matrix levels of just bad.
You know the ending is the darkest part of the Matrix trilogy, right? Like, that's the part where you realize it's never going to get better.
Yeah, and so Brendan was like the Animatrix.
Oh yeah, that's a fun movie. I'll be the animatrix.
Yeah, that's fair.
Oh.
I have a cartoony type talk.
Charming and engaging. Okay, so the first talk I will bring up, because I only wrote down 3, is the trilobite breeding talk. Did either of you see that?
Was not in the room.
Okay.
Oh, is this the eggs one?
Yes.
Or,
The
I
eggs one.
heard bits of the eggs one as I was moving in to see a different talk.
Because we were running 5 minutes behind, and so you saw a third of the eggs talk.
I did.
This was an interesting. The first thing he said immediately made me go, "This makes no sense," and then he got around to trying to explain the thing that made no sense. But
Okay.
he was talking about how they had evidence for how trilobites reproduced. Bear in mind that last year, Tom Hegner and a few other researchers described trilobite eggs from this ornithological Lagerstätten in New York, the Beach's trilobite bed.
Yeah.
Yeah, with these prioritized trilobites, these wonderful gold-looking bugs, and they had eggs preserved at the back of the head. We talked about it on the.
I think we did.
Yeah, we did.
The idea
Yeah.
of potentially a brood pot.
Yeah, but not in the face like people had thought for some reason, but like at the back. So it's like keeping your babies in your like chin flaps.
Your jowls, your
Yes.
jowly bits.
Yeah.
Keeping us on brand.
She did say we should try to Skype at some point if we can. Oh, hang on. Hi guys, it's now officially. No, not that one. I have too many bottles of pills. Here we go.
This is your Paley After Dark Pop a Pill Minute.
Like, these ones keep me good.
Drinking
This-
the pill with cider.
It's got dark again.
Hopefully advisable.
It means I should sleep tonight. Sorry about that. It's 8:30.
We like
Just
to
to
keep
date
him
this.
running.
And so they were saying, he was saying they had evidence about where trilobites laid their eggs.
Okay.
And the first thing he said it was, we have a cluster of 183 meraspids. What is the issue there?
They're not adults.
What is the real issue if he's saying we've got an area where trilobites have laid their eggs, in this hollow we have 183 meraspids?
Well, they're not eggs. They're teenagers at that point.
Yeah, they're not even like babies.
Yeah.
They're like 4th or 5th instar. So he said this, and I was like, sitting there going, okay, do go on.
Yeah.
Because I am intrigued as to where we're going to go with this. And then he said, all these meraspids are the same stage of development. They have a common orientation, but it's not the kind of orientation you'd expect from currents blowing stuff. They like to face in one direction, but it's not so non-random as to not be the fact that someone wanted to face that direction. But yeah, he was saying basically, people use horseshoe crabs, which immediately got me going, do go on.
Okay.
People use horseshoe crabs to say, they're the closest thing related to trilobites. And I was like, there's the issue that these things aren't eggs. They're not even hatchlings. These are middle-aged teenagers.
Yeah.
Anyway, so he was saying they're intact, they're not molts, so it's a mortality. They're the same age, so it's a single hatching event. There is a molted or dead adult there, so this is immediately becoming a much more, German fairy tale type story.
The Pied Piper is taking all of the teenage trilobites to one area that's just far too brackish waters, and the lack of salinity just causes them to fall asleep.
But I'll give him 183 of the same age is bizarre. I also do not believe that 183 of the same cluster could still be fucking alive after 5 months.
Like in one time period?
Yeah, unless they're like spawning millions of eggs, which is possible, but if they're keeping them behind their head, there's not that much space. That's a phenomenal survival rate. I mean, ducks. Okay, I upset my class by showing cute pictures of ducks and being like, ducks can have usually up to 12 hatchlings. 6 will reach adulthood.
Mm-hmm.
6 of these cute ducks are going to die. Of those 2 that reach adulthood, 1 out of each clutch usually survives to reproduce.
Yeah.
And then after the first year, once it survives once, it is increasingly likely each year until it starts getting to a certain point where old age takes its toll.
Yeah.
And so basically there is an experience thing where once you have survived a full year, you are more likely to survive your next year.
So you're saying it's academia?
Yeah. Except ducks don't make this into a bad joke. You are much more likely to be drowned by a bunch of randy men. Because that's what happens to a lot of ducks.
James, why'd you take it weird?
I didn't take it weird, it's true. Ducks do that. Ducks are horrible.
Ducks are terrible.
This is where the question of 1,000 duck-sized horses or 1 horse-sized duck is, please, give me the small horses.
Yeah, no, clearly.
Because those big ducks are terrifying.
Yeah.
They're also basically forest racids.
Yes,
but,
you're right.
Anyway, but then he said, yes, it's really weird that they're back here, so maybe it's a homing thing, and they've wanted to go back where they were born for some reason, and I'm like, okay, so academia, where you want to regress back to childhood because it's a much better reality than the one you're faced with.
I was gonna go with the whole alma mater thing, but okay, sure, we'll go with that too.
Yeah, I was thinking more. Oh, I'll return to my undergrad institution.
Yeah.
So alma mater, I like return and cluster next to the corpse of your old advisor for shelter.
Yeah, because by the time
Again,
you finally
James,
make
you
it
took the
through all
target.
your postdocs, they have to be retiring.
So the upshot of this being, this is weird, and then he provides an explanation for it, while saying that you can make any number of academic bullshit explanations without any data for this.
Okay.
Then his upshot was that maybe horseshoe crabs aren't a good analog for trilobite. I'm like, cool, whatever it takes to get there, ends justify the means. I am not entirely convinced that this is a clutch of trilobites going back to nestle next to the bloated corpse of their mother in the hollow that they hatched in some kind of yearly remembrance.
The many come and they feed upon
Maybe
the
it's
mother.
the children of the corn. Maybe they made that adult commit
They must
suicide.
feed. The babies must feed.
So I have a random question.
Yeah.
It's on the subject of trilobites and horseshoe crabs. Do trilobites have just like random weird eyes places
What?
other than the front of their body, like horseshoe crabs? Like, do they have random
Oh,
light
you mean,
sensitive
well,
cell patches?
so there
We
are
wouldn't know. There were 2 possibilities for trilobites.
there are
Maculae.
pits. There are pits in the glabella, which do seem to independently. I mean, sometimes they're effaced, sometimes they're present there, but they do appear repeatedly across multiple trilobite groups, which could be remnant of ocelli, but we don't really know. We really don't know.
There are swellings on the hypostome, which is this feeding plate in front of the mouth, that people have said could be vestigial eyes, or they could be eyes, but there are no lenses there, and personally, I think they might be muscle site attachments.
That would make sense. Because why would you have eyes directly in the plate that you're using for crushing things? That seems like it's potentially dangerous to your eyes.
Ow.
Well, you gotta check before you bite down. You can see. Oh, that's a pebble.
But
I'll
they
spit
don't
that
bite
out.
down. Trilobites just wiggle themselves and food goes forwards.
Yeah, like they take the arms and they pass the food through the gills up to them.
But at least obsessed with the eyes.
But
so.
I will say,
Okay.
I will say, given the hand waviness that is traditional within paleontology, yeah, sure. There's plenty of evidence for...
Thank you, James, for keeping this a fact-based podcast.
Yeah, well, no, I can't even say trilobites have at least 1 pair of eyes, because a lot of trilobites don't even have that.
Yeah, they're blind trilobites. That's a thing.
Yeah. Maybe.
Maybe.
It's
But
difficult
likely
to say.
not.
I mean, one thing to bear in mind here is that we have very well preserved horseshoe crabs, and we cannot even sometimes see the actual lateral eyes in horseshoe crabs because they are covered by the ridge that goes over the top. We can see the ocelli, but the other light-sensitive organs, to call these other things in horseshoe crabs eyes is a bit misleading. They can see light or dark,
Yeah.
but they're not. They're more like...
But when you're 5 that's what you call them.
Yeah, that's fine.
It's a light dark sensor. It's a primitive eye, and I mean it's.
Yeah, but we can't see those in fossils at all.
I'll
so
make
there's
sure
no way.
by next year that Ellie distinguishes.
That's okay. I mean, anything to keep horseshoe crabs interesting.
Yeah, if your kid's really interested in horseshoe crabs, doesn't matter.
Unfortunately, she's primarily interested in medicine still. So,
a career
I know
that you can make money
on the
off
plus
of
side,
and help people.
On the plus side,
you could do horseshoe crabs, but that's
True.
just horrifying.
More what I was going to say was, on the plus side...
Horseshoe crabs are used for medicine?
Yes,
On
and
the
that's
plus
horrifying.
side, you could stop paying into your 401k, get into a good med school, and then live with her and make her pay for your retirement.
Well, yeah.
You just need to accelerate the development process. Just...
Yeah, it's hard in humans.
Yeah, a little difficult.
Yeah.
Also, it would be really terrifying to basically strip someone of 20 years of their life in order just for you to be able to retire on someone else's medical license.
I don't want to retire.
Well, that's the other option, right? Keep working for free, which is why we have such a problem in academia that we have.
I apologize. I made that one joke, and now I've led us down to a dark path. Brendan, what talk did you want to talk about?
I want to talk about the 3D printed spine.
You
bracket.
fucker!
You got to go first!
Yes.
Okay, right, okay, cool, let's go. Okay, yeah, great, it's a good one.
Never mind.
No, it's fine. We'll do 3 talks today, that's great. We'll do 4, because he's got some bullshit vertebrate up there. This is a visual podcast, Curtis.
I know. That's why I did it.
That's cool, this is genuinely a really good talk, so go ahead.
So it's very similar to what it sounds like. It's 3D printing brachiopods with spines of varying length and studying them in flumes and substrates and looking at what orientations are stable and what the long spines versus short spines help keep you from flipping over, which is very unbeneficial if you are having a benefit of passively using the current to filter feed. And disappearing and scouring and being thrown about, which are all considered non-adaptive options.
Usually people don't.
I
like to be
did that
thrown
in
around,
my 3D printed flume thing. Once you got scoured out and you floated away, I consider that to be not adaptive.
No, I mean it's slightly maladaptive, or
Yeah.
just
Fun, but unproductive.
Yeah, definitely. Yeah.
Yeah,
Your last few minutes of life are wee.
You're not gonna
No,
die. You're not gonna
die.
die.
Depends on where that current takes you.
It gets
If
much
I-
easier for the fish to eat
But
you.
that's not the last 3 minutes. You have a few minutes of like, oh, this is fun, and then you slowly starve to death over a period of days.
Realistically, it's wee. Then still doing this. Oh god. Oh my god. And then the dark realization comes upon you.
It's like if you got on a plane and the plane took off, you're like, this is fun, and then the plane never landed and they didn't feed you.
So the Langoliers. Stephen King reference for you guys.
That had, the movie version of that had some interesting
Bronson Pinchot.
CG.
It had Bronson Pinchot in it. That's all that matters. Bronson Pinchot going, a little girl! Like, just, yeah. Don't watch the Langoliers.
There was some interesting recurrent theme in Stephen King's works.
There are. So, Brendan,
Yeah.
you were talking. So basically, they show that certain spines are potentially beneficial for keeping you in place.
Yeah, and it was a brachiopod, and it had 2 morphs of being either short, densely packed spines versus...
It may have been a kinetid.
Okay, yeah,
Which
well, I
would
mean,
make
because
sense.
Canidid's got the spines coming out the back. I mean, Productids kind of have them everywhere.
Yeah, around
Yeah,
that.
she
Where
showed a
was
picture,
the hinge?
and she showed a very nice printout of the thing. And I, sadly, despite having literally lectured about this 2 weeks ago, which is why I then went to her, found her afterwards, and like, please send me this paper when it's published so that I can make a better lecture. Can't remember whether it was a productive or kinetid, because they both...
Canids are cool because I think in some cases they do have them wrapped around things, so their spines can actually attach. They just come out of the hinge line for the Canidids.
Okay, so this was a productive.
Okay. I mean,
There we go,
here's
we got there.
Here's the thing. There might... I don't remember off the top of my head. There might be some Canidids that have non-hinge line, but productids have spines coming off.
This is the one where basically you've got the growth lines, and then they were formed into little lappets, and those lappets, if it was preserved well, would have been these big spines.
Most likely a productid. Then I'm just throwing that out there, but it again, it's possible. I don't know off the top of my head if there are some canidids that don't just have specifically hinge line, but with some of those canidids, it's cool because they will like wrap themselves around with those little.
They basically act like the bristlefoot in.
Yeah, kind of. Yeah. The wrap around cornerstones.
Did she end up doing more than one substrate, or was it all the same sand?
It was all sand, but she did 6 variants basically, because one of the things that they wanted to do was to actually work out the mode of life, and so was this quasi-infaunal or epifaunal. And if it's epifaunal, it doesn't matter; it just flows away.
Yeah.
And so it's like quasi-informal, and she was putting the hinge either into the water flow, away from the water flow, or like up sideways against it. And was it into the water flow that worked best?
It was whichever way actually made sense with the feeding direction.
Yeah.
So it was
because you have to be able to open up in order to have water pass over.
Yeah, and it was perpendicular to flow direction. I want to say it
that
was with a hinge towards flow direction.
Yeah.
And it was semi-infaunal was the
so
correct.
flows coming this way and they're opening like this.
Yes.
Yeah.
And then just letting water come in through the sides, and that way they're buoyed against the movement when they open.
Mm-hmm.
They don't get
and then they
over.
ramped it up to see if they could scour them out, so they increased the
And
speed.
it can live up to 0.7 meters per second.
Yeah.
That's cool.
Yeah.
And we saw nothing with the Turtella when I did the similar project. It was if you did it in a unidirectional current and you turned it up, it didn't matter. They all got scoured out.
Turtellids are smooth though, like they're like
they don't have spines, but it was variation in the ridging on them.
Oh, okay.
But it mattered in waves. So
interesting.
Okay.
Very interesting.
if you were in waves and you were oriented so that the waves were coming in and washing over you, you would keep staying buried if you had higher ridges. And so,
So that's actually providing resistance against the thing, whereas what these spines were doing, and she used the analogy of tree roots, is they're consolidating the sediment, so they cannot be scoured out because it's packed in tighter.
It would be interesting too to see if then, to some extent, like the success of Productida outside of like through time is partly just a sedimentological basis of these things are able to occupy environments that others couldn't.
Shallower, more.
Because more active environments. Than
or
others.
environments with like strong long short currents
exactly.
or something where
a shift in the sediment cycle. Because I mean they're strophamonata. Like they're part of the clay that does not actually ultimately persist. You've got your strophamonata, your strophomanoids, your plectobonatoids, your productids, and your canidids, and they're this thing along with the billingzellas and etc. And then you've got this whole other clade that includes the orthida that gives rise to the things that we still alive today. So it's this whole diverse division that's a deep division in brachiopods. So it'd be cool if we're just kind of trading successes in individual parts of the clade based upon the available environment.
Mm-hmm. But it was really cool to see, and they, as I said, as Brendan said, they 3D printed it all themselves, and this was an undergraduate project.
Yeah, that's amazing.
Which is fantastic. So
that's really cool. So I saw a talk on creodonts, which are, I think, polyphyletic, but it was definitely they had a tree.
Are they like double thickness oreodonts?
Yeah. It's when you get
Double
two
stuffed.
oreodonts. It's when you get two double stuffed oreodonts and you put them together to get a quadruple stuffed oreodont.
Nice.
No, I think they're carnivorous, and that they gave rise to the hyenodonts, at least in this tree.
I have teeth of those in the collection.
Yeah.
I give them to students in lab. I'm like, mammals, they bury their teeth, dude.
Yes. So the interesting thing about this group, and said it's not necessarily like it's a group that evolves into a lot of other groups, and so it's kind of like you look at the base of things and a lot of different stuff happens. So
They're like angry badgers.
well, the base of this seems to be, again according to this talk, it seems to be largely arboreal, so living in trees.
Cool.
And what they notice is that the basal things are living in trees, and then as we go through time, there is a movement from a closed ecosystem where you've got a lot of trees and not a lot of space that you can run around to in these areas we're removing a lot of those trees and we're opening up grasslands, so we move into an open system. And that's also the time when we start to really develop these things evolve into the hyenodonts.
Okay, question.
Yeah.
Are these things originating in the Mesozoic?
I think they were going into. I think their tree maybe was just the earliest Cenozoic. When they were looking at this stuff. So one of the thoughts they had was, can they find evidence of directional evolution? First thing they did is they said, can we morphologically show habitat, like closed versus open, based upon morphology and morphometrics? So they did a PCA analysis.
Was it just of the jaw?
I think it was a PCO analysis, actually, of all the characters in their phylogeny.
Okay.
And so they mapped out all the characteristics, and they showed that, clearly they could see things that were running, had specific characteristics of the jaw, because you can't move your head around anymore. You got to be more locked in for the neck and the jaw and the head, and various other characteristics. And they showed, we can see cursorial behaviors, running behaviors versus arboreal behaviors, because there's clear morphological signals and skeletal signals. So we can map that onto morphospace. Like, okay, let's take these creodonts, compared to the modern data that we already have, map them onto this, and see whether or not we can see, are these things changing in their distribution on this morphospace through time. But the other thing they did is, because they had a tree, they also then took the morphological characteristics, the raw morphological characteristics, like the whatever morphospace data they had on the skull versus other things, and mapped them onto the tree as continuous characters, and then ran Brownian motion versus Ornstein-Uhlenbeck models to try and see whether there was a truly random distribution on the tree for these characteristics, or a directed evolution on this tree given these characteristics. And what they found was that while they very clearly, the hyenodonts all are moving towards this cursorial behavior and running, everything is statistically following a Brownian motion model. It just so happens that the hyenodonts are this small part of the group that happens to randomly develop this cursorial behavior, and everything else is kind of experimenting with quasi-cursorial, quasi-arboreal behaviors, or characteristics, I should say. And so it's not a set locked model. Instead, they show clearly this is a random Brownian motion model. But when they look at the morphospace, there is a clear trend through time moving from arboreal characteristics to cursorial characteristics and never going back, which suggests a macroevolutionary ratchet.
Nice.
Macroevolutionary ratchet with no selective process. They're changing and they can't change back, but there's no evidence of selection driving the pattern. It was the coolest talk I've seen. Like, maybe in several GSAs.
That's nice. That sounds amazingly cool.
It was really cool.
I agree. I am sorry that I missed it.
So
it was a switch from arboreal to...
arboreal to cursorial.
Cursorial, because you don't go back as frequently from cursorial to arboreal.
Yeah.
Because there are adaptations to climbing and being able to do
and
whatever
when you lose them, you can't. It's harder to get them back.
And so it's the reverse...
But it's not selective moving to cursorial.
Right,
It's random change.
It's like the reverse hyperconivory thing, where...
She basically was talking about hyperconivory and cited Valkenburg's work, and then suggested that one of the possibilities is maybe there's competition for resources that's driving the ratchet based upon other carnivores, and that could be what's actually driving the change. Is like you kind of have to keep going further down this edge. And I mean, there's the whole other idea of potentially it could be competitive, and like there's a maladaptive issue. It could also be developmental. Like if we follow Irwin's idea of you make certain developmental changes and you can't quite go back, but still, it was super cool.
I mean, here's the thing, right? If you've got a different way of positioning your head and how the muscles work because you need to stay stable when you're running after prey, that's going to be different to if you're judging jumping. Mm-hmm. And so going back up, you're going to be the tree kangaroo that falls out and dies all the time because you're bad at what you're meant to be doing.
Yeah.
This is wonderful. We've come so far as a field where we're not just making up stories for everything, and now we've got where the interesting results are potential contingency and a non-adaptive trajectory.
A non-adaptive locking.
Yeah.
Which is at least historically unheard of, because everyone had, I mean, I'm not unheard of, but it's one of those things that had been suggested
That's
by
like
Gould and
failure
Eldridge.
to reject the null hypothesis as far as people used to be concerned.
Yeah, it was like, oh no, clearly there's a change and it's on a direction, therefore it's directional selection. No, there is no statistically significant evidence of directional selection. You can explain it all through a Brownian motion model, and in fact, if you map those characteristics on the tree, lots of those things that aren't going to a full cursorial lifestyle are kind of experimenting with some of these morphospaces, and they're making some of these changes, and it just so happens that when they go far enough down that line, they just don't go back.
That's really cool.
That's really cool. And you are overestimating how much other people are okay with non-adaptive things outside of paleo.
I don't know. I tried to publish in a biology journal, and they were not happy that I talked about things that were not adaptive.
Exactly. It's yeah. I'm with you on that one.
Why are you talking about these characters just being there? Why are they?
I have a reason why they're there. It's just not directional.
I actually got this back in review. This character does something, it wouldn't be maintained in the lineage if it wasn't useful. And I'm like, people.
I mean,
it just needs to not be deleterious.
Yeah, you don't. Just because you couldn't figure out what this was for, it doesn't matter. Even if it's strongly correlated to other things, it has to have a reason. You haven't thought of it. Maybe it changes how it smells. I got that in a review. It changes how it smells. And I was like, well, yeah, maybe, but I have an explanation for why it is there that doesn't need that.
I mean, were you suggesting that something else changes and it's piggybacking with it?
Yes.
Yeah.
So my question to that is, what is the fucking adaptive significance of the appendix that would result in everybody dying if we had slightly less good medicine?
God needs ability to kill you at a moment's notice.
Unfortunately, to do that.
Unfortunately, medicine has prevented him from being able to kill us.
Switch.
Yes.
It's on.
We are Rutger Hauer talking all about the rings of Saturn and tears in the rain.
And then he kills over, goes,
and that was his appendix. His appendix burst. That's what happened. That was a Blade Runner shout out right there. So now back to you, James. What do you got?
The other very interesting, cool talk by friend of the podcast, Roy Plotnick, on Essexella, the Maison Creek jellyfish that what ain't. I think there is currently a push towards reevaluating some of the unexplained fossils in the Maison Creek Lagerstadt, which is a fascinating carboniferous locality where most of the fossils are preserved in these ironstone nodules, and so they are basically hard spherical rocks that people occasionally hit with other rocks, by which I mean hammers.
This James, have you seen 2001? We moved on. We put them on sticks now.
I know. We're in the Iron Age now. We're not in the Stone Age anymore. So we're using iron or steel because we're in a further age, the Industrial Age, and therefore near the senescence of our species' life cycle. We hit them with rocks. Hammers.
This podcast brought to you by
Ivan Drogo.
Ivan Drago?
Yeah. The Soviet hammer.
Oh, yeah, you're right. He was a Soviet hammer. I forgot about that.
I will break you.
Yep.
Also, wait, no, that's not. Isn't that Rutger Hauer? It's not Rutger Hauer. Is that Dolph Lundgren?
It's Dolph Lundgren.
Yeah, Rutger Hauer's a better actor than Dolph Lundgren.
Yeah.
Rutger Hauer's actually a pretty good actor.
No, I was never saying Rutger Hauer's a bad actor.
You were, yeah,
I was saying Dolph Lundgren.
It's not bad.
It's not bad.
No, but
yeah.
Rutger Hauer's one of those really underappreciated actors.
I mean, yeah, it's true. Rutger Hauer is chronically underappreciated, but you must also realise that Dolph Lundgren is an amazing actor considering he can't help but accidentally break chairs. And is so frustrated by his inability to do science by the fact that he breaks pipettes.
Oh my god, I forgot about that joke. That's an old one.
So there's they're found in nodules. There's a variety of weird animals actually what these things are still debated. One of the ones we can't talk about is the Tully monster. One of the ones we can talk about is the H animal, which is an animal that is an H shape, and we go, that's cool, it's the H animal. And the H animal sometimes has T components, and we're almost into pure mathematics here. But one of the things that we thought we knew what it was Essexella, which is a jellyfish. It's clearly a jellyfish. It has a head, a bell, and then it has things coming off of it. But Roy was interested in looking at this because it was also described as having a semi-rigid skirt coming down from the bell, encasing the tentacles, which, as he pointed out, means it would almost certainly have starved to death. And the reason it was decided it had to be a jellyfish is because there was, on some of them, you find a gastropod shell on the skirt, and despite being a completely different genus and clade of gastropods, the person that described it said, this is analogous to this very specific type of gastropod which is parasitic on jellyfish today.
Oh, okay.
And so he broke down the original description and goes, the occurrence of this gastropod is the reason why they say this is a jellyfish.
Okay.
It is the only defining characteristic that they find to say this is a hydrozoa medusoid.
The occurrence of a parasite.
Yes.
That's maybe a problem.
And so he said, so what is it? And then he just turned the fossils upside down. And it was like...
Musical interlude before the reveal.
Sorry, everyone. I'm not taking my melatonin tablets today. Melanin?
Big
Melatonin?
Melatonin.
melanin is
yeah.
what
Melanin is skin.
pigments thing.
It's
So,
skin
yeah, that's
pigments.
why I don't like it, because I feel like I'm eating skin. But
Yeah,
it's
I mean, you
melatonin.
are.
I
Yeah,
am.
you are.
Yeah. Tasty skin.
Tasty skin. Human skin.
Human skin.
The best skin.
Guess
very,
I might-
very long delay before this reveal. What is it when it's upside down?
Yeah.
Oh, yes!
I have to know.
So he turns it upside down, and then he starts looking at the fact that it's
The
unusual.
blastoid or something.
No, oh, that would be amazing though.
That would be really
Um,
amazing.
I'm trying to think what the skirt would be.
There are striations in the skirt,
Okay.
and there are bulbous structures. And the bulbous structures are tubercles of a sort, and the striations are, he thinks, are muscles on their longitudinal axis. And the bell is a disc-like shape. And so his suggestion is that it is a burrowing anemone. And it looks very uncannily similar to other burrowing anemones. And the fact that there are these striational muscles, there are 6 of them, it is a hexacoral, and therefore it is an anemone.
Okay.
And he has pictures of it next to modern burrowing anemones, and the morphology is uncannily familiar. And there's a couple where the fossil just ends away from the disc, so the skirt goes up and then it's just a solid straight line, and it just ends. And people said, oh, it's weird that it's not preserved here. That is exactly what the oral cone looks like when the tentacles are retracted in an anemone.
Okay, so it's like a desiccation issue. They retract as it dies, and it's like...
Yeah.
Yeah.
And some anemones can move, and they wiggle around like perverse little sacks of flesh, and they just...
They escape your bowl.
Yeah.
You put in your
Yeah.
touch tank.
And then the interesting thing is that there are not many trace fossils preserved in Maison Creek.
Okay.
But in the Pennsylvania and Illinois, everywhere, it's lousy with burrowing and anemone trace fossils.
Interesting.
But there are no burrowing and anemone body fossils.
Except there are.
Yes,
Yeah.
in the Maison Creek, where the preservational style is different, we don't get the trace fossils, but we do get the body fossils.
Interesting.
So that was fascinating. And the funny thing was, he said, so if you turn it upside down, I'm like, it's a fucking anemone. It's a goddamn fucking anemone. And then he like 4 slides ago, it's an anemone. I'm like, Jesus Christ! Why did no one just go, oh?
It's all about perspective, James.
Yeah. The other thing they were doing is they were using a real big sledgehammer to crack a nut. There's a new imaging system at Yale where they can, because he's sabbatical there.
Yeah.
And you can do basically directional light and take it from many different angles and then layer it over the top of each other. And so he was showing in super fine detail. It's the way to image Maison Creek. We struggled with this when we were looking at stuff. This is the way to image Maison Creek because this stuff looks almost three-dimensional in these 2D photos.
Yeah.
And you can start picking out the different layers. And so this is why he was able to say these striations are internal, these tubercles are external, and things like that.
Okay.
So he was doing it's really cool stuff. Graham Young, who is a hydrozoan worker, is on it, and so he's got multiple people, like including jellyfish experts, going, yeah, this ain't jellyfish. So that was really cool.
Brendan?
Jackson's Coral Triangle talk?
I did not see Jackson's Coral Triangle talk. Oh wait, yes I did. This is the one for nitrogen and whether or not we can use nitrogen to find coral.
Tasty nitrogen.
Or was this a different one?
This was the Coral Triangle one.
You're just saying the same words.
I'm sorry. The Coral Triangle versus Caribbean one.
Okay, I apparently didn't see this one.
Did it involve cursing a question asker?
No.
Wait.
No.
Do start at the end and then work backwards, please.
It was friendly.
Do I need another drink?
No, I need better notes.
You don't remember what happened in this talk?
So this talk, it was about, so it was bryozoans and looking at fossils in Indonesia and in the future in the Philippines as well, but at the moment Indonesian corals and bryozoans, and looking at what the diversity pattern is in a place where they don't get whacked with a big reason to die, like the Mediterranean.
I mean, no one needs a reason to die. Anyway, go on.
I have one slight question. Maybe I'm being dumb, but is like Indonesia like tectonically like wedging into the Philippines?
There's Wilson's line, right, where you've got a different.
Wallace.
Sorry, Wallace's line. Wow.
Wilson's the football.
Yes. You've got Wallace's line over there around the South Pacific, where you've got two plates that are clearly different from each other, and so even though islands are closer together, one island is more closely related to, I believe, Australia, and the other is more closely related to mainland.
Yeah, there's a deep water
division.
Yeah.
Yeah, well, I mean, Wallace was coming up with this biogeographic. It's one of the first biogeographic studies.
Yeah, it's fascinating because this
before
is the thing.
tectonics.
And also this is like the thing that Darwin has in his notes, but never seemed to realize, and this is the big thing.
Well, I mean, again, this is Wallace, and Wallace was the contemporary. Like, they both came up with the same idea.
Yeah, but Darwin never realized the biogeographic component was really important.
Yeah, even though it was one of the things that definitely brought him to evolution in the first place.
Yeah.
Anyway, go ahead.
So the question was why is, diversity so much higher in Southeast Pacific versus the Western Atlantic.
Okay.
And
Pacific's hotter.
Huh?
Pacific's hotter.
That doesn't seem to work.
That's my null hypothesis. We'll go from there.
The Pacific is hollow?
Hotter.
Okay.
Yeah. With the upshot being that you don't really know whether the diversification rates are higher or whether the speciation rates are higher. They said diversification rates, but that's what led to the questioning, which led to the, you know what I mean, and fun moments of friendly jossing, cursing out your questioner. But the upshot is, well, we have the Panama Paleontology Project, we have what's grown out of that, we have Gulf coastal plain work and all of that, so people have done this in the Western Atlantic, but have not done this for the fossil record in Indonesia, Myanmar, etc., etc., etc. So there's rock, but people are only beginning to get through what the fossil is. So we know the modern's really diverse here, it's less diverse here. We know what the fossil is really well in Western Atlantic, but we don't know what the fossil record is very much in the Western Pacific. So they did the bryozoans, and the bryozoans look the same. in
Okay.
both. So even though there's the higher diversity in the modern, the rate that they're diversifying seems entirely controlled by the extinction rate, where you cut off the food and the Atlantic gets weird and then it gets cold and unpleasant. And then the other coral locality is, the Mediterranean, where we had the
Salinity crisis.
death of the Mediterranean.
Yeah. Yeah.
So it may not be that something's really special in the Coral Triangle. It may just be that they suffered the least, and so if you've
That is, in fact, how most things get through life.
Trying to suffer the least as much as possible.
yeah,
Yeah.
and it was the kind of thing that
Some people bizarrely and sadly suffer far too less.
Yeah, it was interesting, and it was a fun talk, but it was very much I think that it ended with something like, I'm definitely going to be dead before we have the answer to this,
Yeah, I
but
mean,
somebody needs to do this for a decade and see what, a decade to 30 years, and then we'll know.
That's cool.
So call for people to go and find coral fossils.
So let's see. I've got like 3 different ones that I kind of want.
I'm out now, so
You're completely out. Okay.
Yeah.
I got one thing to mention, but I
Okay.
don't have any other.
All right. So let's just start with Jablonski.
okay. Yeah, I want to hear what this was. I was in a conversation.
So this starts with a look at latitudinal diversity gradients, because a lot of the stuff that Jablonski's worked on is still latitudinal diversity gradients.
Mhm.
And one of the things that he did was he looked at latitudinal diversity gradients versus functional diversity gradients and versus taxonomic evenness. And so what he found was that species concentrations are higher in the tropics, functional groups are higher in the tropics, species evenness, so how evenly things are distributed across space, is higher in the temperate and polar regions. So it seems like even though we have higher diversity in the tropics, it's not necessarily evenly spread around. There's more wider range of abundance, which was interesting. Then he transitioned to talking about mass extinction events
Okay.
in a way that I kind of feel like these were. Kind of feel like
Two talks.
I feel like he might have been really interested in functional groups, and he applied functional groups to the latitudinal diversity gradient stuff. Said that's cool, and then was like, let's apply it to mass extinctions. And the thing that he found was he basically looked across. He called the 2 mass extinction events, which the 2 mass extinction events he considered to be true mass extinction events were the Permian and the Cretaceous. And I think it's just because he's specifically looking at mollusk groups, so he's looking at the things that actually affect his groups. And that's fair. That is fair. So he looked at mollusk extinction across the Permian and mollusk extinction across the Cretaceous, and he defined, and he actually did a series of definitions based around functional groups. And he showed like the presence of different functional groups, and he basically did, and if you assume these interpretations, then this, and if you assume these interpretations, then this, and talked about sort of the ways that functional groups might be, how interpretations of functional groups might potentially bias the data. But even then, even if we do that, all it really does is kind of minimize the pattern that he shows even further, which is that mass extinction events across the Permian and the Cretaceous don't really attack functional groups at all.
And in a way that's less than you expect from randomly sampled.
I mean, like just simply. That's the next part is that, and so she showed like a hollow curve essentially where there's like a majority of one functional group and then like consistently less as you keep going. And what he basically said was like maybe 1 and realistically probably none in the Permian, and maybe 2, but realistically maybe 1 in the Cretaceous. And then he said, and if you were just to cause random extinction across this tree, it would kill more functional groups at the level than are actually lost.
Did you say the word tree?
Well, I said tree.
Okay.
Across all of mollusca that was alive at the time.
Okay.
Because I'm still assuming that all mollusks are, united, because that's a thing. He did try to correct for phylogenetic biases in functional groups. He kind of, sort of he talks a little bit about, like, these things are found later on in lucinids, so because they're related, I'm assuming that this group actually, this functional group survives.
Yeah, the one that would alternate a few times would be the symbionts. Would be, we're not positive these had symbionts, so we could
Yeah, and there were a few things where it's like, if we correct for the possibility that these functional groups are more of a Lazarus taxa, essentially, that it's like these things are we know these things are related, so these things don't actually go extinct. So there was some kind of phylogenetic correction based upon knowledge of the larger trade. And so like functional groups just don't go. And so he's like, so this means that, like, weirdly enough, these have to be there's multiple hypotheses he was coming up with for trying to explain this. Maybe one of them was like, maybe extinctions are targeting functional groups that have higher abundance or higher species diversity. Maybe extinctions are not selective against functional groups, but are selective against something else that is piggybacking to allow functional groups to survive. I was sort of sitting there kind of like silently going, or maybe ecology and evolution don't completely map to one-to-one. And I don't know how much was taken into account in terms of whether or not functional groups can re-evolve. Like the polyphyletic nature of functional groups, I don't know if that was something that was considered. It was an ambiguity of the data. Like he was clearly talking about ways that monophyly could preserve functional groups that looked to go extinct. So clearly there was this idea in there, but I was not entirely sure with the way he presented the data.
Because there are you theoretically, like crossbills and squirrels technically are the same functional group. They're both nutcracking vertebrates. They're not closely related. So there's an extra facet to this that could be explored further.
Yeah, and again, I don't know.
Yeah. That's.
I think it did have the good line that space doesn't substitute for time. That was a good line.
Yeah.
I wrote that down because. Paleontology.
Because I think what he was essentially doing was, let's just take before and after and see whether or not we preserve functional groups. And then if we know we clearly have an ancestor that gives rise to something else, then clearly that functional group has still survived. Yeah. And so to that extent, he's not necessarily allowing for enough time for the functional group to re-evolve.
Right. Yeah, no, that's fair. I think the interesting thing is, aside from random patterns, it's not enough is being lost for it to be a random pattern. It's almost like true mass extinctions are non-selective, are more random in terms of.
But so he was saying if you had a truly random against species, you would lose way more functional groups than expected at the level of extinction experienced in the Cretaceous and the Permian.
But if you were selecting against whatever happened to be the
dominant group,
you'd be more likely to be classified as a mass extinction.
Yeah, if you function against the dominant functional group, you're going to still preserve the dominant functional group post-extinction, and everything else can be spared and still survive.
So maybe it's more a broad level community destabilization without
taxonomic, potentially even like environmental or geographic selection, truly functional guild level
that's
selection.
Geographic, I don't see how you can have a taxonomic selection against a taxonomy. It's not like an asteroid came down and went, fuck dinosaurs. It was like, no, dinosaurs were just in a bad place. It wasn't because they were dinosaurs.
No.
It's what they were.
Yeah, they were occupying a niche space that became hurt. Like broader speaking, like pulling this out into niche evolution is different from
disease.
What you're saying is that fox die in the past was dino die. Yeah, that makes sense. Brother! Anyway.
It's taxonomy, so it'd be sister.
That's fair. It just doesn't work as well when you do the liquid snake joke. Yeah, sorry.
Oh, sorry, that was a joke.
Yeah, it was. Okay. It was a reference, actually. It's the worst type of humor, actually.
The Paleo Society headband. We can do the eye patch.
I could. Yeah, I could.
He's.
I could definitely do that. I already am Snake, so that doesn't matter.
He has 100% snake costume.
Yep, I could do that. That's not a problem.
We're prepared now.
Yeah. So, Otacon, you want to tell us about that thing you were talking about?
I talked about weird snails.
Okay.
That's what I like to talk about.
Okay. What you said? You said you had something that you wanted to a comment you wanted to make.
On what?
You had a comment. You were looking at the Alf Museum thing.
Oh yes, the Alf Museum. I just think that's awesome because it's a 170,000 specimens, and it's a high school.
That is pretty awesome.
The Alpha Museum is a high school?
It is a high school museum. They do 16 people classes where they're like, that way they can control what they're doing, and then they have volunteers, but it is a high school.
I had
And
no
that
idea
was
the Alpha Museum
awesome.
was a high school.
Yeah, I saw there, gave the talk, apologies. And it was awesome and amazing, and that needed to be commented on. Because I did not know that was a high school either.
Yeah, that's fascinating.
I saw Corey's talk.
Uh-huh.
She was doing sort of small scale or very, very micro scale analyses on mollusk fossils, looking specifically at shell microstructure and also doing chemical analyses of shell microstructure to show that in between their Cretaceous sediments, she was comparing to modern mollusks and modern clams and ancient clams, and she was showing that in between the actual crystalline patterns, we get these darker areas that are actually made out of carbon, and then she suggested that they even had carbon isotopic signatures similar to what we see within simple peptide bonds.
Mm-hmm.
So
not isotopic signatures.
it's not isotopic. Sorry. Yeah, they were band energy. They were bands. We were getting similar bands associated, energized bands with peptide bonds, and so was potentially making the argument that we were preserving proteins in 65 million year old rock record.
And the interesting opposite argument that they seem really glycine rich, and glycine's really simple.
Yeah.
And if it's possible that the organic material that's inside that's around the prismatic component of the shell structure just is glycine rich.
Yeah.
The other possibility was they were 20-year-old museum specimens, and that could have been sufficient time to rapidly simplify to the glycine rich.
That within 20 years, the natural complex peptides might have just immediately degraded to glycine.
So obviously she will go to Wegmans or whatever the Wegmans equivalent is and take a quahog and cut it in half and do fun stuff, and she will know the answer to this very rapidly.
She is in New Mexico.
Yeah, I don't know.
They do not have the wonders of Wegmans.
Whatever the equivalent of Wegmans is, the Wegmans analog, wherever you get a quahog plant.
It's a Safeway, actually, when you're that far west. You go to the Safeway.
I didn't know if things migrate out
There's
from
Safeways
California.
in the UK. There's Safeways in the UK. I'm pretty sure they're infringing on copyright.
I really appreciate the green that has come across your arm because of the
Yeah,
copper.
it's one of the reasons why I tend to wear them so far up usually, so that I do not get the copper banding around my left hand.
So that was potentially cool. And then the last thing that I saw that I thought was interesting was the nitrogen talk about corals and whether or not we can, in the fossil record, identify corals that had photosynthesizing symbionts and those that did not.
Which, interestingly, nobody had looked for one in the fossil record that did not before.
Yeah, that was an interesting complication.
Okay, this is interesting because there was just a paper published saying that they found an extinction event where things went from photosynthesizing to non-photosynthesizing.
Okay.
Corals.
So what this was looking within data from the Triassic? And
it was the Miocene, and
there's some of the Triassic.
The test case was Miocene, I
Okay.
think, and then there was a recrystallized Oligocene one, and they wanted to see if diagenesis affected it. And then I can't remember what the third age was.
It was variable. It was a very variable time in the Triassic.
That's when sound is
It's
defeated.
Triassic. Yeah, clearly. That's when you go into the center, you do a scream that unmakes the world. Anyway, let's keep going. So basically, the corals. They did a test study on modern corals, looking at nitrogen isotopic ratios, and what has basically been suggested before is that there might be like a division between the a sort of linear trend from available seawater and the nitrogen that you see, and then the nitrogen that is taken into these specific corals, depending on when they're symbiotic or asymbiotic, and that the two lines should essentially be like divergent from each other by a set amount, so that you got one line on top of the other.
The complication being that while the offset was fairly consistent, the
the seawater has a consistent
needs to be characterized.
Yeah. So clearly, there is some amount of overlap in certain variable seawaters, and so they did a series of modern corals to show that this linear relationship was true, that it worked, and then they went to a bunch of corals that had been previously named as symbiotic or asymbiotic, largely based upon patterns of their morphology. If they tend to be growing towards the surface, it suggests that they're growing towards the light, like as opposed to if they don't necessarily have a consistent trend for all the polyps to move to the surface, as well as aspects of the environment that they're living in. Clearly, if something is living in an environment with that has suggestions of being being a deep depth, they're probably not in the photic zone anymore, and so you probably can't have photosynthesis.
Yeah, the test case was they tried to pick one that was definitely deep enough that it was not.
Yeah, and so then they compared those to their modern, and they found that they could fit on those curves, and that furthermore, if the assumptions are correct in terms of their symbiotic nature, you could potentially use that to back channel back to the seawater.
Slightly less confidence in that last bit, but the comparison of co-occurring ones and there being an offset and that telling you something
was cool.
Was good.
It was very cool.
And they did it with two different methodologies, one that involves destroying more and one that involves being better in every way.
Two different methodologies. One of them.
Yeah, one is newer. The newer one is better, and it seems to work. It involves destroying less sample, and it works better. Which is nice when that's the combination.
I might know that. We just had a talk about, we've been trying to buy a machine. We just go...
You've been trying to buy a machine that destroys less?
Yeah, you just go dunk, and it takes like a small less than a millimeter, and it just vaporizes the first little bit, then takes the gas, rather than having to like carve out a section of it with a laser.
Fun.
Cool. That sounds cool.
Well, does anyone have anything else they want to talk about?
Brendan's notebook looks like something you'd find pages of while going through an abandoned hotel or a wood before being murdered by either Brendan himself, as his notes get more and more crazy, or the thing that was hunting him.
Put into PCA. PEEM.
PEEM. Yeah. Now I know what PEEM stands for.
Now you know what PEEM stands for.
And
then also, is that James or
Zanes?
Zanes. Okay, and it's in quotes because I thought for a second there was James and then peptides, and I was like, what?
No. I just have terrible handwriting, and I didn't expect anyone else to read this except for the one thing where I wrote out what PCA is because my undergrad asked.
Okay, that's good.
So this was the only thing that was intended to be legible by anyone.
Okay. So all I'm saying is that exists, and if any of us start feeling the urge to start recording voice journals for any reason, fucking stop.
Okay.
Okay.
Sure. Yeah, that's fine.
I'm glad that I can use my tiny book to frighten you in the future.
James was talking about me needing to stop these recordings. I don't know why. Brendan seems fine. Every single time, he always seems to smile, and then when he holds out his knife, he lets me look at it for a while, glistening in the night. Anyway, I'm going to stop recording right now.
But they're so hard
suspiciously next to this body that I just found.
Oh, I found this body.
It's always how it is. Like, you go 2 feet, and the bad guy just gave a recording about the evil thing that they did, and just decided to leave it there for the protagonist to find.
Yeah.
I just beat Rise of the Tomb Raider. The whole thing was just nothing but that. Like,
oh, God.
I just got betrayed, and then immediately I turned the corner, and they left me a nice little document about why they betrayed me. By a character, meanwhile, that gets introduced in this game, who I forgot was a thing, and so there's just this whole thing like, you betrayed me, and I'm like, who are you again? Should I know you? And I'm going on the internet being like,
Did we meet on the subway?
who is this person?
So what I'm hearing is that Rise of the Tomb Raider is slightly maybe a less tight game.
It is a YA movie.
Which of the two guys did you choose?
I had to He accidentally got shot in the chest, and
Okay.
then he was an immortal prophet, and I needed to stop his immortality in order to stop the evil that he had unleashed like thousands of years ago and wanted to stop. Whoops.
So what you're saying is that Tomb Raider went from a believable, interesting story to bullshit.
I mean, did you
But
not
he's
see
also
the
saying
end
that
of the
he
first Tomb Raider?
fixed.
I got confused because I beat that boss fight with one bullet and then emptied 12 clips into a dude in the cutscene. So
So the Rise of the Tomb Raider is literally the exact same game.
okay.
Like all the way down to you'll have a midpoint where you reach the immortal enemy that you're going to have to face that looks vaguely like samurai people, and then you're going to have to fight the zombie samurais again, and suspiciously they keep dropping bullets, and then eventually you will climb a tower or something that is falling apart in order to get to the top to have a boss battle, and then finally end it.
Okay.
Yeah.
I forgot about the samurai in Tomb Raider.
Yep. The immortal samurai.
Yeah. They were cool, but...
You get they're technically not samurai because they're Russian, but they're totally the immortal samurai.
What kind of... Well, I don't know enough about Russian folklore.
I don't know if this game does either.
Were they little babushka dolls?
No, because the whole thing is it's like an ancient Greek prophet that has been living forever, and he migrates his people into Russia, and then they get ostracized, and then this whole government group that is essentially the Knights Templar from the Assassin's Creed called the Triads is after them, and they killed...
No, Triads is a different culture.
They killed your father, and he was getting too close, and then they killed your father by actually making your mother-in-law was actually secretly the person who killed your father.
So what you're saying is it's the second set of Spider-Man movies.
It's bad. It's just bad. It's bad. The story did not compel me in the slightest, and I finished that game largely out. Yeah. I mean, the core mechanics are great. I just wish they would develop it. And Rihanna Pratchett is still a great writer, and when there's the moments of little character, it works, but she's very clearly working in a giant institution that's not letting her actually do anything. Anyway, that's an aside. No one has anything else to add?
I made James draw a smiley face,
You did.
and I felt proud.
Yeah, it was a really good, enjoyable, fun talk.
Brendan gave a good talk.
Yay.
I'm surrounded by people that are making dumb animals with no morphology interesting. It's kind of worrying.
Thanks, James.
Yeah.
Right back at
no
you, buddy.
morphology. But mine still have living relatives, so I can do genes.
I had a question, actually. In vermicularis, the bit that coils, is that a protoconch?
No.
Okay.
So protoconch is like what's secreted by the shell gland, so the like very larval shell. And so it's usually the totally unornamented, very tip that falls off that you comb through tons and tons of sediment for.
If we wanted to have one more discussion, and I think this is an important discussion, corals that have faces.
No. Reef-forming animals that have faces.
I'm just
Corals
saying-
don't have faces.
I'm just saying, can we think of some other reef-forming animal that has a face?
Do you think
Crinoids.
that a bryozoan has a
Crinoids.
face?
No. But, I mean...
But their face and ass
they-
are next to each other. That, like, it's ambiguous.
I mean, again, this all comes down to how do you define face? If it's just a mouth, clearly corals has a face.
No.
And they also has an ass. It's the same thing. Delete it and look
No,
it out.
you need an oral end and
aboral
sensorial sensorial organs concentrated near it. That's how I'm defining a face.
Okay.
Something that can peek out at you.
So cephalization.
Yeah. Yep. And the bryozoans, they're tiny and they have an end, but you that's the one that I'm ambiguous on. But
So what you're saying is somebody needs to tell us whether or not bryozoans have a face.
see, I've mostly gotten no's when I ask this question with no context. So
What about serpulates?
they're not like
Do bryozoans
they don't
have
make
a
reefs
face?
by themselves.
That's true.
It's
Because I was going to try to say something about oysters, but unfortunately, all the bivalves have reduced the face region to the point where they don't really have a face anymore.
Yeah, a string of eyes doesn't count as
Google
a face.
surprisingly is not helpful for do bryozoans have a face?
Well, it's almost an opinion question.
I mean, crinoids don't have eyes as far as we know, do they?
I want
And they're
to
only
say no.
reforming in the Mississippian when they die. So,
I feel like you need to talk to Scott about this.
This has taken long enough
Okay.
that my argument of them being reforming things with faces is sufficient because this is weird, and if it takes this long to think of another explanation, then it
I
qualifies
will
as
give
weird.
you
That's fine. That's
a lot
fine.
of like money, maybe $10 whole if you write that exact sentence into a paper.
This
that's
is weird.
published.
Yeah, no, definitely. Your argument should be, it took a lot of time to come up with anything else. We couldn't. It was weird, and so we stopped. QED.
No, what I really want is Vermicularids, the only reef-building organism with a face, just in a paper.
So, what are you a reviewer for? Which journals?
Paleontology.
That sounds bad. I need to do the morphological tree with the fossils and something. I'll put it in that.
I really want there to be like some sort of advertisement, just a picture of the vermicularid and just like a circle image that says the only reef builder with a face.
It's your friendly, relatable reef builder.
Yeah.
I can put you guys in a new reef home today.
When all the corals are dead,
The frustrating thing
this is
like,
the thing that you'll have to save because it has a face. You can see it with its cute little eyes going, please don't let me get covered in algae.
I desperately want to think of something, but I can't.
I can't either. Ants sort of make like their own. Some ants make their own like stitched together community. It's the closest thing.
So
I
like
can
a
think of.
fire
There's well-known
ant raft.
marine reef
Yes,
building
yes.
ants.
The fire ant raft is the thing that I'm thinking of. It's literally engineers. Have you seen the stuff that engineers do with fire ants to try and like because it apparently behaves like a fluid that is
I've
completely
seen
unique
them,
to
like,
anything else.
Put on the giant gloves so they don't just get swollen up palms from
Yeah.
being bitten and formic acided. And that it's just like it's like a cat doesn't want to go somewhere. It's just like
Yeah, and you can. It's
Did
pretty
you
amazing.
is that an ignoble that the cats act as solids versus liquids
that might
paper? Because there's a depending on context, cats will fill the volume that they're in, and so it characterized cats as transitioning from solid versus liquid properties.
That volume is Amanda's microphone. that's the volume that the
Oh my
cats will.
god! I
will
really hope by next week she's moved that goddamn catnip plant.
You know she won't.
I know
She just rubs it on the microphone every time, right?
because Curtis said, "This is a teach you'll learn moment. What did you learn?" I'm like, "Nothing," because she never does.
Well, I think that's probably going to do it for today. So I guess we'll be back tomorrow to discuss whatever the heck we saw tomorrow.
Mm-hmm.
Cool.
I have to go figure out what that will be.
Indeed.
That
me too.
sentencing just broke my brain.